Hello everyone, my name is Ryota Takenaka. Today, I will be presenting my midterm semester examination report for the integrated systems technology. The topic of my report is the design of a digital platform using a domain-driven design approach. For my case study, I have selected Mercari, which is Japan's most popular consumer-to-consumer marketplace. First, let's look at introduction. The objective of this report is to apply DDD principles to a real-world example. I will systematically identify Mercari's core domain, designing its external API integrations, and map the relationships between different contexts. So, what is Mercari? It's a C2C marketplace platform primarily used on smartphones. The key feature of Mercari is that it is an escrow-style service, not just a simple Valentine board. This means when a buyer purchases an item, Mercari holds the payment. The platform only releases the money to seller after the buyer confirms that they have received the item. This escrow system is crucial for building trust and safety in C2C transactions. The basic flow is very simple. First, a seller lists an item and a buyer purchases it, and they holds the payment. The seller ships the item, and the buyer confirms that they received it. The platform releases the payment to the seller, and finally, both parties review each other. As you can see in Table 1, we have the key stakeholders. This includes the seller and the buyer, of course, but just as important, platform Mercari itself, which manages the marketplace and payments. The payment service provider, like a credit card company, shipping carrier, and consumer support, DDD helps us manage the complex interactions between all these stakeholders. Now, let's move to the most important part of DDD, identifying the core domain. As noted in this first section on the core domain, the core domain is a fundamental value of the business. For Mercari, I have defined the core domain as the entire flow from listing to purchase to transaction. Why is it the core? Because this flow is how the business fundamentally creates value, enabling individuals to sell items and completed transactions safely is the backbone of the entire platform. Automating this flow is what leads to success. Next, we break this system down into subdomain and bounded context. In this table shows the subdomain I defined in this section, and I've clarified four. First is transactions. This is the core domain we just discussed. It manages the complex set of transactions from paid to shipped to completed. This is where Mercari creates its unique value. The next is payments. This handles everything about money, authorization, capture, and refunds. It's essential, but it supports the core. We use external PSPs for this, so we classify it as supporting. The next is shipping. This handles label issuing, tracking, and delivery. Unlike payments, it's a vital support function, often relying on external carrier APIs. The last is authentication and authorization. This is a login and user management system. It's a solved problem and can be replaced by external tools, so it is generic. For each subdomain, as detailed in this next part, we define a bounded context. A bounded context is a clear boundary where a specific domain model and language apply. First, the transaction BC is responsible for the transaction life cycles. And next is the payment BC. Payment BC is responsible for communicating with external PSPs, and the shipping BC handles integrations with carriers. And last is the IMBC handles user authentications. This separation is key to managing complexity. Next, let's look at the domain model design for the core domain. Please see figure 2. This diagram, which corresponds to this part of the report, shows the main entities and value object for the transaction-bounded context. The central piece is a transaction, which is an aggregate root. This means it's a main entity that controls life cycle and ensures all rules, or in, or invariants are protected. For example, the transaction agrees ensures that the statute cannot change to shipped before it is paid. We also have the review entity. More importantly, we have value objects. These are small, immutable objects that represent a concept. First is a trade state. This isn't just a string. It's a value object that defines that valid states created, paid, shipped, received, and so on. This prevents us from ever setting an invalid statute. And next is money. It's an object encapsulates the amount and the currency together, which prevents errors in calculation. And finally is a transaction fault and rating. Also moderates as a value objects to ensure they are always valid. In this reflection section, I reflect on the advantages and challenges of using DDD. The main advantage is organizing complexity. By centralizing rules in the transaction aggregate, we prevent logic from being scattered all over the application. It also gives us a ubiquitous language, meaning developers, designers, and business stakeholders can all use the same terms, like transaction or trade statute, and mean the same thing. This makes the design resistant to change. And next is challenges. The main challenge is that DTD has a steep learning curve. It takes time to learn concepts like agreements and bounded context. It can also lead to over-engineering if you apply it to simple problems. Next, in the major section, we look at public API integration. A platform like Mercari cannot exist without external APIs. I have identified three essential ones. First is a Stripe API. It is for payment processing. This is for handling credit card payments, and most importantly, the scroll. The second is the shipping carrier API. It is for logistics. This is needed to issuing shipping labels, get tracking numbers, and confirm delivery. And third, SendGrid API. It's for email notifications. This is used to send a readable transaction email to users. For example, your item has shipped. As we can see, the bounded context we defined earlier are responsible for these integrations. So, first is a payment BC. It owns the integration with Stripe API. It uses a pattern called an anti-cooperation layer, which I will explain yet. And next is shipping BC. It uses adapter patterns to manage multiple different carrier APIs. And next is a notification BC. Makes direct calls to SendGrid API. The context communicates with each other using asynchronous domain events like payment authorized or shipment requested. Next, in section 4, context mapping, which is about how these contexts interact. I will focus on the most critical interaction between payments BC and the transaction BC. The business scenario detailed in this section is the main transaction flow. First, a buyer confirms the purchase, and the transaction BC asks the payment BC to authorize and funds. The payment BC tells the PSP to create a manual capture payment. The funds are now held. And later, when the buyer confirms receipt, the transaction BC tells the payment BC to capture the payment. And the payment BC tells Stripe to finalize the charge, and the money is moved to the seller. And next, to manage this relationship, we must select a context mapping pattern, which is discussed here. As shown in figure 4, I have selected ACL patterns. And here is the justifications. First, the external PSP is upstream and our transaction domains is downstream. We do not control the PSP's API. The language models might change. We must protect our core transaction domain from being corresponded by the PSP's external language. The ACL acts as a transfer. For example, when the PSP sends a webhook event called payment intent succeeded, the ACL transacts this. It publishes a clean domain event in our own language, such as payment authorized. This protects our core domain model. And finally, let's look at the message flow. Detailed in the final section in figure 5, this sequence diagram shows the entire scenario. First, it starts when a buyer confirms the purchase, and the transaction context sends a command, authorize payment. And the payments context calls the external PSP to create the payment intent. And the PSP sends back to authorized webhook, and the ACL translates this into a domain event. Payment authorized, and sends it the transaction context. Now the transaction state is officially paid, and the transaction context can now safely send the create shipment command to the shipping context. And the buyer confirms the receipt when they receive the item. The transaction context sends the capture payment, and next, the transaction the ACL tells the PSP to capture, and the PSP sends a captured webhook, and the ACL translates this one to a payment release. And finally, the transaction context receives this event and moves to the completed state, sending a notification to a buyer. This diagram also shows an alternative flow for authorization, failure, and optional refunds. So, in conclusion, this report has demonstrated how domain-driven design can be used to model a complex real-world platform like Mercari. By identifying the core domain, separating concerns, bounded context, and using patterns like the anti-corruption layer, we can build a system that is robust, maintainable and aligned with the core business value. This concludes my presentation. Thank you very much for your attention.